Currently, second year BSIT at BSU Alangilan, and we're here at Chapter 8, Subnetting the IP Network. And this is the first activity, calculate the subnet mask basic. First, in the Chapter 7, we all know how to convert a binary to decimal and decimal to binary. So in Chapter 8, is it somewhat just applying what we know in Chapter 7. Then let's try to answer this activity. You are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet fields provided. Additionally, convert the subnet mask to the prefix notation format in the prefix notation field. And as you can see, we are given in a subnet mask and we need to find the binary and the prefix notation of it. So let's try to answer. As you can see, 255 means it's the octets is all ones, because the sum of all octets that is all ones is 255. So it's 1111111. Then another 255, another 1111111, and 252. And as you can see, 252 is minus 3 in the 255. So the first and the second one is 0, because the value of this first 0 is 1 and the value of this second 0 is 2. So 1 plus 2 is 3, and 252 is somewhat missing 3 value in 255. Then as you can see in this 0, it's all 0. So this would be the subnet mask in binary. Then the prefix notation would be, you would count all the ones and put this slash, then let's try to, it's 8, then 16, then 22. Then let's check. As you can see, we have the correct answer, and let's try another one. 1 to 8, then reset, then 255. As you can see, the third one is the only number that change, so it will be 111, and as you can see, the value would be 1 and all zeros, because this one is 1, 2, 4, 8, 16, 32, 64, and 1 to 8. 1 to 8 is the last number, so it is somewhat equal to this. Then another one would be 0. Then the prefix notation would be 17, because 8 plus 8 plus 1 is equal to 17. Let's check, and that's correct. This is the second activity of Chapter 8. The activity, determine the numbers of bits to borrow. Instruction, you are given the number of hosts that are needed. Determine the subnet mask that would support the number of hosts as specified. Enter your answer in binary decimal prefix notation format in the field. So 25, it is the host needed. So I've already answered it, and it's a bit easy, and we can always, so it would be 111, 111, and 111. Then the last would be, the hosts needed are 25, so it would be like this. I'll explain it, because it's 2, 4, 8, 16, 32, and with the 32 host, the host that we only need 25, and the 32 can accommodate all the 25 hosts, and the subnet mask would be 255.255. Oh, it's here, it's been already saved. Then 224. Then it would be, as you can see, it's 8, 8, 8 plus 3. It would be 27 slash 27 prefix notation, and the host needed here is 1000, so it would be the prefix notation would be in 20s or something, because as you can see, this part only have 526 hosts that can accommodate, and then let's try, it would be 1. Then this one would be have some zeros, because of the hosts needed are 1000, so the last one will be 0, plus 2 ones will be 0, and because as you can see, let's compute 2, 4, 8, 16, 32, 64, 128, 256, 512, then 1000 above. Then as you can see, we already just need 1000 hosts and it's already 1000 above. Then the subnet mask decimal will be 255.255.252 because why it's 252, it's because it's it's a 1 and the value of this first two zeros is 1 and 2, and you should plus that and minus it to the whole subnet mask 255, then it would be 2520. Then it would be 8 plus 8 plus 6, it would be 22. Then we only need, as you can see, we only need 75 hosts. It would be just like this. Then 75 hosts is because the value of this is 2, 4, 8, 16, 32, 64, 128. So 128 can accommodate a 75 host. Then it would be a 25 prefix notation and 255.255.255.128. So let's see. Then this one is pretty easy because the host needed is so few. Then it would be all ones, and 2, 4, 8, 16, 4 zeros. I think it will be 4 zeros. Yes, it's 4 zeros because 2, 4, 8, 16 can accommodate 10 hosts. Then it would be 255, 255, 255, and 240 because so you can see 1 plus 2 plus 4 plus 8 is minus 15, so it would be 240. Then it would be 28. Prefix notation would be 28, and this one say this is the 500 host. This would be all ones, and 7 ones and 1 zeros in here. That's right, 10 all zeros. Then the notation would, the subnet decimal would be 255, 255, 254.0, and the prefix notation would be 23. It would be 23, not 22. 23. So you can see all the answers are correct, and let's proceed to another third activity of the chapter 8 subnetting IP networks. It is somewhat called the part 1, practicing VLSM or virtual length subnet mask. Then let's try to answer it. We will drag the description or the answer to this one. Then new subnet mask decimal would be a 255.255.255.192 because it's only the one who is an independent in here. As you can see, it's a new subnet mask. Then the first prefix notation would be /26. Then as you can see, the first full subnet range, it is somewhat in a sequence or organized manner, so it would be in just a 063, 0 to 63, then 64 to 127, and 192 to 255. Then let's check. So you can see we are all correct. Then let's proceed to the part 2. Then the part 2 is this. I think it's the new VLSM subnet decimal would be 224, and the prefix next notation would be /27. Then the other one would be 64 to 95, I think. Yeah, it's 64 to 95. Then the last full VSM would be 192, and the second subnet range from /26 from table 1 would be this. And as you can see, it's all correct. VLSM or the variable length subnet mask, and this is somewhat a problem and the requirements. Subnet the 172.16.00/23 network to create the following subnet. As you can see, we need a network, one network with 500 hosts, one network with 200 hosts, one network with 110 hosts, one network of 5 hosts, one network of 24 hosts, one network of 12 hosts, and 4 point-to-point networks for 2 hosts each. Then as you can see here, I've listed the host values and the decimal values for the magic numbers. Then let's go, and as you can see, first let's get the subnet mask of this, because let's see if the IP address or the subnet can apply or accommodate this 500 hosts. Then as you can see, we're going to the largest to smallest host. Then so you can see 172.16.00 have a prefix of 23, so it's 111111 and 1. And as you can see in here, the magic number in here is 2. And as you can see into the host value would be 2, 4, 8, 16, 32, 64, 128, 256, and 512. So it can accommodate 500 hosts. Then this would be like this. It should be have some. I'll display 2 IPs in order to accommodate one of the 500 hosts, and the other one is in order to use for one network of 200 hosts. Then this will be like this. I've used 172.16.2.03 as a one network for 200 hosts with the prefix of 24, because in 24, as you can see, it can accommodate 256 hosts, or I'm not saying about all the usable hosts, but the total addresses in the subnets. Then the 4x4, then so you can see the magic number is 1, so this would be 2.1. And so you can see in here the subnet have changed. Then we will erase that because we've used that in this network. Then we're going to the network of host of 110 hosts. Then we will still remain the first network, and we will use the second network as network IP as for the 110 host. Then we will delete that and copy it with the 25 prefix in order to get a 110 host. As you can see, we can 128 host can accommodate 110 host. Then the magic number is in 128, so the next IP would be 172.16.2.128. Then we will remain the first IP address. Then the second IP address will be used in order to get the one network of 55 hosts. Then paste it here. Then 172.16.2.128 with the prefix of 26, and as you can see in the prefix of 26, the magic number is 64, so the next IP would be 128 plus 64 would be 172.16.2.192, and we will stay with that 172.16.2.128 with the and use 172.16.2.192 as for the next network host with, and we will use that 172.16.2.192 for the with 27 prefix, and the magic number for that is 32. So 192 plus 32 would be 172.16.2.224 in order to get the next IP address for a 824 host, I mean. Then we will use the second IP address in order to get the second host, the 12 host, then we will use that and make it a 28 prefix, then 172.16.2.224 plus 16, and it would be 240, and the final IP address would be 172.16.2.24/28 prefix, and the magic number, as you can see, is in the 28 is 16, so that's why it will add some 16. Then we will use the second IP in order to get the final, the port point-to-point network for each two hosts. Then we will gonna make as for the final point-to-point 4x4, it would be /30, so 172.1.16.2.240. The 30 is 1 2 3 4 5 6. As you can see, this is the 4. The 4 is the magic number, so it would be plus 4 for 240 plus 4 is 244, then another one. Then as you can see, we've completed the requirements in order to subnet it. Then that's for point to point, then one network of 12 hosts, then one network of 24 hosts, one network of 55 hosts, one network of 110 hosts, one network of 200 hosts, and one network of 500 hosts. And as you can see, all the IP address hasn't overlapped and is still accessible because it doesn't overlap, and in the IP address we can clearly say that all are different and all are usable. That's all for the simple learning about the VLSM, or the variable length subnet mask.